Okay, so just I will continue with a new section 15.2, but in fact it is a continuation of section 15.1. It's about double integral. So just to make things clear, just I will recall what we did so far. Basically we can say we did just two things, two main points. So we started with the volume problem. The volume problem. And it is the following you have. So we have a surface, some surface here, z equals of xy, and we have some region here, some region. Okay. The volume problem is to find the volume of the solid below the surface and above the region, Okay. So I need to find the volume of this solid here. Okay. And the answer was given as follows. Volume equal double integral over r of xy, the equation of the surface d dA. So this is the solution of the volume problem. Then طبعا dA here, dA to be either dx dy or dy dx. Okay. Okay. The next main question is really how to set up the limits of integration. Okay. And it depends on the region R. And last time we considered the simplest type of regions R when R is a rectangular region. Okay. So this is the first case. R is a rectangular region. Okay. Yeah, someone is busy with something else. So we hear someone talking with another guy. Okay. 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 So let me just write this. So this is a rectangular region. So this is A, and this is B, and this is C, and this is D. So this is the region here. Okay. And a rectangular region is written or described as follows. You take the x interval AB times the y interval CD. Okay. So in this case, to set up the limits of integration, we set it up as follows: of xy dA equals double integral of xy. Okay. Now dA here, we can choose dx dy or dy dx. Both will work. Okay. I can choose dx dy. If I choose dx dy, then the inner integral will go with the inner differential, and the outer integral will go with the outer integral, with outer differential. The inner integral you are integrating with respect to x, so the limits will be x values. What are the x values of the region? To be the x interval from A to B. So I write A to B. The outer integral will go with the outer differential. It is with respect to y, so I choose the y values of the interval. The y values are the y interval. I could C to D. Or double integral of xy. Okay. I can choose dA to be dy dx, and dx dy. I can switch between them. Dy dx. I can change the order. Dy dx. Then as above, the inner with inner, outer with outer. The inner integral is with respect to y, so I choose the y values of the interval, which is the y interval, C to D. Outer هيكون from A to B. Okay. So this is how integration when R is a rectangular region. Okay. So this is what we did previously. Okay. Now we start new things, new material. Now, okay. Now we choose now a new type of regions too. Let me say without number. هنا R because a general region. A general region, okay. And we have two cases, two basic cases, okay. One is called type 1 region, type 1 region. Okay. What is a type 1 region? It is given as follows, okay. So we have, this is the X and this is Y. And this is, let me see again. Okay. So this is A and this is B and this is Y equals G2X and Y equals G1X. So it is a region between two curves, a region between two curves. Okay. The lower curve y equal G1, the upper curve y equal G2 of X. A region between two curves, a region above the x-axis, between two curves, a lower curve and an upper curve. Now we need to describe this region. Okay. R, we describe it in set notation. This is the set of all points x, y in R2, such that. We need to describe this region here. Okay. Now, to describe this region, you take the following. Okay. You take an arbitrary point. So I will choose arbitrary point, for example, here. This is H, the point X and Y. This is an arbitrary point. Now for this point here, what is X? Well, this is X. This is X. Okay. I need to find all possible values of X. And this is the R is the set of points X, Y, and R2 such that X. I will concentrate first on the X coordinate. What are the possible values of the X coordinate? Okay. What are the possible values of the X coordinate for this region here? Here for this point, it will be X will be a point between A and B. Well, will it X take all points or just one point? Okay. I move the point here around. Okay. Move it to the left and move it to the right. You get X here and X here and X here and etc. So really, you will cover everything. All points, X will take all possible values between A and B. Okay. Let me just make it clearer. Okay. Pay attention because I will make things a little bit slow and in detail. Okay. So let me just make this clearer. Okay. So this is H. This is the region here. So this is A and this is B. Okay. Now, if I take in a point X, Y, X will be here. What about if I take another point here now? Let me take X here. This is an X. Where is X? This is X. Okay. So this is X. So another point between A and B. Choose XY to be here. Okay, to be here. Where is X? This is X. Another point between A and B. Choose a point here, for example, XY. Okay. Where is X? This is X. Okay. Another point between A and B. Okay. So for this point, this is arbitrary. Move it around in the region. Okay. You will see X will take everything between A and B. Will cover the whole interval. Okay. As we explained here. Okay. So here the possible values of X for this region. X will be between A and B. X will take all values between A and B. Okay. Okay. X will take all possible values between A and B. Okay. But this is for the possible values of X. Okay. If this is clear, please write one in the chat. If it is not clear, you can ask now. Okay. If it is clear, write one in the chat. So just follow me. I am going slowly. You should be able to understand this easily, inshallah. فهنا okay, so this is for x. يعني it is very simple. يعني x we take arbitrary, so this is x. If I move x around, x will move around the interval, along the whole interval. So x will take all points between a and b, all values between a and b. Okay, this is for x. Okay, now for y, we go to the y, for y. Okay, now for y, I will work on for 1x, and for 1x, for this specific x, what are the possible values for y? This y will be 1. Okay, for to this, just you just draw this line here. Okay, and you draw the line here. Okay, and as if you are going in the direction of the y-axis. Okay, now here the y value here, which is inside the region, what are the possible values for this y? Okay, we can find it as follows. We have in 2 points, this point here and this point here. Okay, okay, يعني one in the lower curve and one in the upper curve. Now what are the coordinates? What are the coordinates of this point here in the upper curve? You are choosing x, so the x coordinate will be x. What is the y coordinate for this point? To find the y coordinate, I have to substitute in the curve y equal g2x. So when I substitute x, I get g2x. So this is a g2x. The same thing for the lower point here on this line. What are the coordinates of this point? The x coordinate is x. The y coordinate you have to substitute in g1. So it is a point in the lower curve. هتكون g1x, g1x. Okay. So now on this line, okay, specifically the points in the region here, x is fixed. X is fixed for any x, it's fixed. Now what about y? If I move this point up and down, what are the possible values of y? The y values, it will be between the y of the lower curve, the y value of this point in the lower curve to the y value of this point in the upper curve. And حتكون from g1 to g2, from g1 to g2. I will cover everything. If I let this point move up and down, I will choose everything between g1 and g2. So I will say y between g1x to g2, g2x, between the lower and the upper. Let me make it clearer for you. Let me make it clearer. Okay. Okay, so this is another way for the y. Okay, for the y. So let me take another curve. So take again the same region here. So this is the region here. So this is A and this is B. And this is our region. Okay, our region. Okay. Now here I will take a point here, just an arbitrary point. And for this is H, the X. Okay. But to make it clear to us, to understand, I will take a specific, some number between A and B. Let me call it, for example, 4. Okay. And this is H, Y equals G2X, and this is H, Y equals G1X. If you choose a specific H, X, for example, X equals 4. For what is this point? هيكون 4 and Y, 4 and Y. What are the possible values of Y? On this line, just you continue the line, I will have these 2 points, هنا and هنا. Okay. In the lower curve and the upper. What are the coordinates of this point? X is 4. What about the y coordinate for this point? You substitute in G2. هتكون G2 4, G2 4. What about the y coordinate here? Okay, X is 4. What is the y coordinate for this point? You substitute in G1. هتكون G1 4, G1 4, G1 4. Okay. So here, when x equals 4, يعني for this at this point here. So for you have this point for y, you just move it inside the region. What are the possible values of y on the whole region, on the whole line? Okay, the possible values of y will go from the y coordinate of the lower curve to the y coordinate of the upper curve, يعني from G1 4 to G2 4. Okay. حتكون y حتكون between G1 4 to G2 4. So in this case, I covered all points on this, all points here on the region. If I move X around, I will cover other points in different lines. Okay. So this is why when you say in general, when you take an X, any X, and what are the possible values of y will be between the y coordinate of this point to the y coordinate of this point, i.e. between G1 to G2, and write y from G1 to G2. Okay. So this is for y. Okay. Okay. Now, is it clear for y or not? Okay. Is it clear? Okay. If it is clear, write 2 in the chat. If it is how to find the the possible values of y. Okay. Write 2. Okay. Okay. For now, this is now. Once you have this one, طبعا, this is how it is done in detail. But to simplify our work later on, really. And notice, once you take the interval, x interval, the limits of y are lower curve to upper curve. What is the lower curve? G1. What is the upper curve? G2. So y will go from the lower to upper. Okay. If you want to do it without really this explanation. Okay. Now, in this case, this is how we describe the region. Once we describe the region, we are done. Okay. Now, how to set up the limits of integration? Double integral over r of x, y, dA. It is double integral of x, y. Now, the rule here says the following. Now, what is dA here? It is, you have to take dy dx. You cannot take dx dy. Okay. فحتكون dy dx, dy dx. But this is the rule. Okay. For rectangular region, you are free to choose dx dy or dy dx. You have these two options. But for a region of type 1, a region between lower and upper, you have to choose dy dx. Okay. Now the inner integral will go with the inner differential. Now dy, so I integrate with respect to it, I need the limits of y. What are the limits of y? Well, they are given in the description here, between G1 and G2. So this is G1 x to G2 x. Then the outer with respect to x, I take the x interval of the region from A to B, Okay. In other words, once we know the description of the region, that's it. These are the limits of x. These are the limits of y. Period. Okay. Limits of x and limits of y. These are the limits. Okay. The description will give you the limits of the integration. Okay. Okay. So this is what is good type 1. Okay. Type 2. Type 2. It is really similar, but now you just work on the y-axis. So when you do something like this. Okay. This is x, and this is y. And this is you have a left curve and a right curve. So this is C and this is D. And this is the region here. And this is a curve x equals h1y. And this is x equals h2y. Okay. A left curve and a right curve. If it is left and right, we write them as x equals a function of y. As function of y. And right. هنا lower and upper. And I work on the x-axis. Now I work on the y-axis. It is really the same thing, but you're just rotating yourself. Okay. For now, just how to describe this region here are, it is the test of all points x, y in R2, such that, okay. You do exactly the same thing. Okay. فهنا you take just arbitrary point here. We take arbitrary point x, y. So this is x, y. So just take a line on the y-axis. So this is y, the y coordinate y. Okay. What are the possible values of y? Okay. From C to D. Okay. If you move this point around, up and down, always y, the y will be the point from C to D. Okay. A y between C and D. What about x? You take just a line, continue the line here in this direction. This is the, what are the coordinates here? The y coordinate is y. The y coordinate is, what is the x coordinate? You substitute in the equation of the left curve. When you substitute, you get h. For x equals h1y. h1y, okay. What about here? Okay, the y coordinate is again fixed, y. What about x? You substitute in the right curve. When I substitute, I get x. So what is x? h2y, h2y, h2y. So xy, this point here, the general point here, xy, the possible values of x will go from the x coordinate of this point to the x coordinate of this point. From h1 to h2. From h1 to h2. Okay. يعني from the left curve to the right curve. Left curve to the right curve. So this is the description. Once you get this description, in fact, this description will give you the limits of integration. Okay. So here, double integral over r of xy dA equals double integral of xy. Here, if it is type 2, dA will be dx dy. So I have to write dx dy. I have only one choice, dx dy, okay. And then writing the limits from the description. Inner with dx, outer with dy. What are the limits of x? h1 to h2. h1 to h2. What are the limits of y? Well, from c to d, c to d, c to d. And type 2, it is exactly like type 1, but it is, yes, instead of working on the x-axis, you work on the y-axis. Lower upper becomes left, right, left, right, okay. And this is H, type 1 and type 2. And these are really the three basic regions in chapter 15 as a whole, okay. So you have either rectangular region, very simple, or regions of type 1, which is geometrically a region between upper and lower and upper curve, or a region of type 2, geometrically a region between left and right curve. Okay. One observation you have to keep in your mind. Okay. One observation. Okay. Keep it in your mind. It will make life easy later on for you. Notice the outer limits in type 1 or type 2. Okay. The outer limits are numbers. Okay. From A to B. The outer limit, type 2, numbers from C to D. The inner could be numbers or functions. Functions, but the outer always are numbers. Okay. Which numbers are they? Well, you have to, the numbers are specific also. Either you take A to B, this is the X interval. If you take C to D, it is the Y interval, okay. The outer will be either the X interval or the Y interval, okay. You can see it is always known. You can easily find them, okay. The outer, make sure they are numbers. They have to be numbers, and it will be either the X interval or the Y interval, okay. So keep this in your mind, and life becomes easy later on, okay. Okay, so keep it in your mind. Now let me give you an example, just to show how to do this, okay. Example. Evaluate double integral over r of x plus y dA, where r is the region bounded by the curves y equals root x, y equal to 0, and x equals 9. Solution. I hope you are following me, inshallah. Yani, are you following me or busy with something else? Okay.
Yes.
So pay attention, inshallah. As I told you last time, if you follow me, you will understand the main ideas easily, okay? Okay, so now, I'm going slowly and giving lots of details, so pay attention. So evaluate this integral, double integral. Well, to evaluate, I have to set up the limits of integration. To set up the limit of integration, it depends on R. I have to know what type of a region do I have. Is it a rectangular region? Is it a region of type 1 or a region of type 2? Each type has a rule to find the limits of integration. So how to decide which region am I having it? I have to sketch the region, where R is the region bounded by the curve. So sketch the region and see what it is. Okay, is it a rectangular region, a region of type 1 or a region of type 2? Okay. So you go and sketch the region. So this is y equals root x. This is y equals root x. Y equal to 0, it is the x-axis. X equals 9, this is x equals 9, okay. This is x equals 9, okay. The region is this one, this is h, the region, okay. Okay. Clearly the region is not a rectangular region, not a rectangular region. So the first option is out, okay. So it is either a region of type 1 or a region of type 2. And follow me, please, okay. Do you think this is a region of type 1 or a region of type 2? What do you think, okay?
Type 1.
Type 1.
Geometrically, what is type 1? It is a region between a lower curve and an upper curve. خلي دائما الجيومتريك meaning يعني in your mind. Type 2, geometrically, it is a region between a left curve and a right curve. Okay. What do you think انت هذه type 1 ولا type 2?
Type 1.
Type 1, Doctor.
Okay. Is it type 2 also?
Can be type 2 because left to right.
Exactly.
دكتور معلش
خلينا نشوف
بس
type 1 قبل. خلينا نشوف type 1. If it is type 1, what is the lower curve? What is the equation of the lower curve? Okay.
Y equals 0.
What is the x? What is the equation of the upper curve? Okay.
Y equals the square root of x.
It is very simple, lower and upper. If it is type 2, what is the left curve?
Root x.
Yeah. What about the right curve? Okay.
X equal to 9.
In the 9. Okay. It is both in fact. But don't worry هنا طبعا خلي شوي هنا. As you go in, things becomes even again. Now I will solve it. I will solve this. I will give you the solution now without worrying هل هي type 1 ولا type 2. واضح ولا لا؟ Okay, so pay attention. Okay. Now here just I need to remember إنه إيش always the outer integral has to be إيش number صح ولا لا؟ Number. Which numbers? Either the x interval or the y interval. معروفين هالnumbers. The x interval of the region or the y interval of the region. Period. يعني very simple. Okay. But I will start with this. Now the outer. Here I will choose first to be in this first solution here. I will choose x to be. I need the outer to be the x interval. I need the outer to be the x interval. So for this region here, what is the x interval of this region here?
From 0 to 9.
0 to 9.
0 to A.
0 to 9. Okay. هذه نعم مش A. Okay. 0 to 9. Okay.
No.
Okay. The x interval of this region from 0 to 9. Okay. So this is H, the outer. So now I need the inner. The inner حيكون y صح ولا لا y. Okay. Now for y I have to go H in the direction of y. Okay. In the direction of y. Okay. Fine. We take a point here x y. So I go something like this. This is x. This is for this. So I need to know what are the possible values of y. Okay. What are the coordinates here? Okay. حتكون x. What are the coordinates here? This is x. What is the y coordinate here?
Y equals 0.
0. Exactly. What is the
0.
x coordinate here? Here for the upper
Root
point.
x.
Root x.
Square root of x.
So for this x, y will go from the y coordinate to the y coordinate. From 0 to root x. From 0 to root x. From 0 to root x. Which is another geometrically, y will go from the lower curve to the upper curve. The lower curve y equal to 0, the upper curve y equals root x. Now, what is this is r طبعا خلاص, this is ايش r, okay. This is the description of the r. Now the limits, okay, so the description هم نفسهم ايش الليمت, okay. الآن double integral over r x plus y dA, okay, x plus y. I decided what is the outer. What is the outer? 0 to 9. صح ولا لا? That's 0 to 9. But this is r. Now, what is the differential corresponding to the outer? Is it dx or dy? Okay.
dx.
dx. Yeah, x is moving from 0 to 9. dx حتكون natural. This is very simple. So this is dx for the outer. The inner limits of y from 0 to root x. 0 to root x. Then the inner حيكون dy. So these are values of y, so the differential حيكون dy. Okay, dy. Okay. That's it. Okay. So notice I set up the limits of integration without worrying هل هي type 1 or type 2. Now you evaluate. Evaluation is as usual. You start with the inner, then the outer. Now هنا integrate with respect to y. The integral of x with respect to y حتكون ايش؟ x y plus integral of y with respect to y, this is y طبعا, حتكون half y squared from y equal to 0 to y equals root x. And these are the limits. Substitute y with root x حتكون هنا x root x plus half root x squared minus 0. So this becomes x3 over 2 plus half x. This is the value of the inner integral. After evaluating it, I bring down the outer integral. So this is h integral 0 to 9 differential dx. And this is h, a simple integral from math 101, math 102. This is h x power 5 over 2, 2 over 5 plus 1 over 4 x squared from 0 to 9. Okay. The calculation is given in the note, so the final answer will be 234239 over 20. So check the calculation in the note. Okay. So this is the solution. Okay. Notice I solved it without really worrying هل هي type 1 or type 2. Okay. Now let me do another solution. Here I choose the outer to be the x interval. I will now choose the outer to be the y interval. Let me see what will happen. Okay. So now this is, I choose the same region here. This is y equals root x. And this is x equals 9. And this is the region. Okay. Okay. Now the outer, I need it to be y interval. This is x and I need it to be y. بمعنى, this is your region here. What is the y interval of your region here? يعني work on the y axis. Work on the y axis. What is the y interval of this region here? Okay. From what?
From 0 to 3.
So this is 0 until the y here. This is the y. The y here. Okay. صح ولا لا? Okay. What is this y هنا?
3.
X equals 9, you substitute, you could y root 9, which is 3. So this is 3. Okay. So the y interval of the region from 0 to 3. That's it, 0 to 3, 0 to 3. And very simple, not difficult. Okay. Now inner, خلاص ضربنا as inner معناته x. الآن for the x معناته حتاخذ ايش؟ Just you go in this direction. Left, right, or take a point, a general point in x, y. If I choose a point here, x, y, x and y, and this is h, y, you just continue the line here. Okay. So find the coordinates here and the coordinates here. What are the coordinates here? The y coordinate is y. What is the the x coordinate for this point here? Okay.
9.
9. It is fixed. 9. It is on the line. 9. Okay. Now here, this point here, the y coordinate is y. The y coordinate is y. What is the x coordinate for this point? For this point?
Y squared.
This point lies on the parabola y equals root x. I need x. So we just solve for x. Get x equals y squared. So the x coordinate will be y squared. So here y will go, x will go from the x coordinate here to the x coordinate here. Okay. The x coordinate y squared. The x coordinate هنا حتكون from y squared to 9. Okay. أو على طول, what is the left curve and what is the right curve? The right curve x equals 9. X equals 9. What is the left curve? Left, I have to write the function in terms of y. X equals y squared. X equals y squared. Left and right, x is a function of y. Okay, you keep this in your mind. Okay, left and x is a function of y. Lower and upper, y is a function of x. With these little things, when you combine them, things becomes really.
Doctor?
So this is R, this is A, this is the description of R. Yes,
the output be with the constant.
في تقطيع لصوتك, your voice is not clear.
The outer one to be with the constant.
Always the outer integral will be constants. Which constants? Either x interval or the y interval of the region. Okay, and they are not just any constant. No, there is a description for this constant. It will be either the x interval of the region or the y interval of the region. And in fact, in almost all, I don't want to say all, in almost all of the question, almost, not all, you can do either. Okay, you decide which one is easier for you. Okay, almost all, not all. Okay, but in this case now I am done. So just let me write the limits of integration. I'll set up the limits of integration now. So now in this case, double integral over r of x plus y dA equals double integral of x plus y dA. Now you choose the outer to be from y from 0 to 3. So this is 0 to 3. What is the differential corresponding to this 0 to 3? Is it dy or dx?
dy.
خلاص انت you take y معناتها dy خلاص. These are y values حيكون ايش dy. Okay. The inner حتكون from y squared to 9, y squared to 9. These are limits of x. X from this to this. The difference حيكون dx, dx. And then again you just say start with the inner, evaluate the outer. And the details of the calculation are given in the notes also. So I will not do them here. You will get the same. We get the same value. Okay, we get the same value. You can check the details. 2, 3, 4, 9 over 20. I wrote, just to confirm, and really you get the same answer. I did both calculation in detail. You can check them in the note. Okay, the detailed calculation and substitution and evaluate. The details are given in the note. Okay. And you get the same answer. Okay. So this is really how to evaluate. And to summarize, just sketch the region, and then if it is not a rectangular region is very simple. It is the easy case. Now you have the other two cases, type 1, type 2. Always keep in your mind, you choose, you start. You want the outer to be x interval or the outer to be y interval, and then the other will be either you go horizontally or you go vertically. Okay. If I choose the x interval, okay, then for y I have to go in the direction of y. Okay, vertically. This is the direction of y. If I choose the y interval, okay, then for the x I have to go in the x direction, left to right, left curve, right curve. This is how to do this calculation. Okay. Okay, if it is clear, this is one example here. If it is clear, please write, I don't know which number, write 3. If you have a question, you can ask now.
دكتور يعني الحين واحدة منهم تصير معادلة واحدة تصير رقم.
again.
يعني ما يصح الاثنين يطلعوا لي ارقام، لازم الانر ديفرنشال يصير عباره عن معادله.
هذا اذا كانت rectangular region، اذا كانت rectangular region في بروبلم هنا صايره. اوكي اذا كانت rectangular region خلاص هي حتكون بوث.
لا اقصد في حق درس اليوم اللي هو التايب 1 و 2 ما يصلح يصير بوث ارقام صح؟
نو ما اذا كان بوث ارقام حكون rectangular region. اوكي
تمام.
يعني اوريدي هو معطيك الان كله كيرفز، يعني الباوندري حيكون كيرفز. اوكي
اوكي
كيرف لور كيرف ليفت كيرف رايت كيرف. اوكي فاتكنت بكل نمبرز. اوكي نعم.
هذا كلو يعني لما نعرف الكونستنتس والفانكشنز الباوندريز، ان الكونستنت هم راح يكونوا دائما الاوتر.
بالضبط. يعني this is a basic thing. This will help you. Always the outer will be constants. وagain مش any constant. They are either the x interval or the y interval. يعني they are specific يعني. Okay. But this makes easy make life easier for us. Okay. Now هنا now طبعا there is no time to give example, so I will give more examples. I will record a video during the weekend, maybe today or tomorrow. So please check it just to give more examples, okay? So that before you come next class, at least the idea should be clear to you, okay? Also, when we come to next class on Sunday, I will add something and give more examples. But before you come, please read watch the video that I will make, inshallah, during the weekend. It will not be, inshallah, long video, but please read it. It will be just more examples. Okay, more examples with one trick. Okay. Now here we have just let me say, just remember, just next week